My dear students, today I am going to teach you the second part of Latin square design. This is statistical analysis of M by M Latin square design for one observation per experimental unit. Let Yijk I is equal to Ijk is equal to 1, 2 up to m. Denote the response from the unit that is plot in field experimentation in the ith row, jth column and receiving the kth treatment. If S represents the set of m square values, then symbolically Ijk belongs to S. If a single observation is made per experimental unit, then the linear addition model is Yijk is equal to mu plus alpha I plus beta j plus gamma k plus epsilon I j k. This is star and Ijk belongs to S. This is our addition model of LSD, where mu is the constant mean effect, alpha I, beta j and gamma k are the effects due to the ith row, jth column and kth treatment respectively, and epsilon Ijk is error effect due to random component assumed to be normally distributed with mean 0 and variance sigma e square. That is, epsilon Ijk, it is epsilon Ijk follows normal distribution of mean 0 and variance sigma e square. Is it clear? If we write, you see, if we write Z is equal to, this is Z is equal to grand total is equal to y triple dot is equal to total of all the m square observations. Total of all the m square observations. Ri is equal to, we write y double dot. This is total of the m observations in the ith row. Total of the m observation in the ith row. And Cj, we write this y dot j dot is equal to total of the m observations in the jth column. Then Tk, we write Tk is equal to y double dot k. This is total of the m observations from kth treatment. Total of the m observations from kth treatment. Then we have, you see, summation yijk minus y bar triple dot whole square is equal to summation y bar I double dot minus y bar triple dot, this is ijk belongs to S, plus y bar dot j dot minus y bar triple dot plus y bar double dot k minus y bar triple dot, then plus yijk minus y bar I triple dot I double dot minus y bar dot j dot minus y bar double dot k whole square plus 2 into y bar triple dot. If we simplify this, we get this. Then we write in this way. You see, is equal to m into summation I y bar I double dot minus y bar triple dot whole square plus m into summation j y bar dot j dot minus y bar triple dot whole square plus m into summation k y bar double dot k minus y bar triple dot whole square plus summation, here ijk belongs to S, yijk minus y bar I double dot minus y bar dot j dot minus y bar double dot k plus twice y bar triple dot whole square. Here the product term vanishes since the algebraic sum of deviations from mean is 0. Therefore, here you write this total sum of square. Total sum of square, this TSS is equal to SSR plus SSR, that is row sum of square, plus SSC, that is column sum of square, plus SST, that is treatment sum of square, plus SSE, error sum of square, where TSS is the total sum of squares and SSR, SSC, SST and SSE represent sum of square due to rows, sum of square due to columns, sum of square due to treatment and error sum of square respectively. And this is given by total sum of square is equal to, you see, total sum of square, I write simply here TSS is equal to summation yijk minus y bar triple dot whole square, ijk belongs to S, then SSR is equal to, you write SR square is equal to m into summation I y bar I dot dot minus y bar triple dot whole square. Then you write SSC square is equal to m into summation j y bar dot j dot minus y bar triple dot whole square. Then SST is equal to ST square is equal to m into summation k y bar double dot k minus y bar triple dot whole square. And SSE is equal to SE square is equal to total sum of square minus SSR minus SSC minus SST. This is SSE. Now we represent this in a table. This is ANOVA table from LA for m by m LSD. You see this ANOVA table for m by m LSD. ANOVA table. Here source of variation, then degrees of freedom, then sum of square, then mean sum of square, and variance ratio. This is our ANOVA table. Here source of variations are rows, columns, treatments, and error. And for rows, degrees of freedom m1, for column degrees of freedom m1, for treatment degrees of freedom m1, but from error degrees of freedom is m1 into m minus 1 into m minus 2. Here total degrees of freedom m square minus 1. And sum of square we write here for column SR square, for row SR square, for column SC square, for treatment ST square, for error SC square. And then mean sum of square, this is SR square divided by degrees of freedom, SC square divided by degrees of freedom, ST square divided by degrees of freedom, SC square divided by degrees of freedom. Now I write this m SR square, mean sum of square for row, is equal to SR square divided by m minus 1. Then m SC square is equal to SC square divided by m minus 1. Then m ST square is equal to ST square divided by m minus n. Then m SC square is equal to SC square divided by m minus 1 into m minus 2. Then we find variance ratio. This is F, variance ratio F. We get here 3 variance ratio for row, column, and treatment. FR is equal to m SR square divided by m SC square. Then FC is equal to m SC square divided by m SC square. Then FT is equal to m ST square divided by m SC square. Here we get 3 variance ratio. and this is our ANOVA table. Then we set up the null hypothesis. You see, let us set up the null hypothesis for row effects. We set up the null hypothesis. Let H alpha, here alpha 1 is equal to alpha 2 is equal to up to alpha m is equal to 0. Then for column effects, we set up the null hypothesis H beta. Here we take beta 1 is equal to beta 2 is equal to up to beta m is equal to 0. Then for treatments, HT or tau is equal to tau 1 is equal to tau 2 is equal to up to tau m is equal to 0. The variance ratio FR, FC and FT follows F distribution with m minus 1 into m minus 2 degrees of freedom under the null hypothesis H alpha, H beta and H tau respectively. Let F alpha is equal to F alpha degrees of freedom m minus 1, m minus 2 be the tabulated value of F for m minus 1, m minus 2 degrees of freedom at a level of significance alpha. Thus, if Fr, you see, if Fr greater than F alpha, we reject H alpha. And if Fr less than and equal to F alpha, we may accept H alpha. This is very important. Similarly, we can test for H beta and H tau. H beta null hypothesis and H tau. And these are the statistical analysis of M by M LSD, one observation per cell. LSD for one observation per cell. Thank you.